Can I start?
Yes, you're all good.
Okay, so thank you very much. So my name is Giovanni Sileno, and I will present now part of the work in which I'm involved together with Matteo Pascucci, Thomas van Binsbergen, and Tom van Engers. And so that's about DPCL, which is a language template for normative specifications. So everybody's experiences that we are passing from a view on computational devices as individual devices to much more to digital, to the idea of digital social systems. So we have around us a lot of examples that show this direction the technology is taking, if it's already taken. So that means that we are passing from mechanical view to computation to institutional view of computation. In the sense that we are not anymore interested into the instruction component, which has a focus on performance, but on contracts, regulations, laws, where the focus is on coordinating expectations. So let's assume that we accept that we have a need to represent normative directives, but how we are going to do that? So there are at least three questions that I can identify, I found around in the literature since the 70s, so since the legal expert literature a long time ago. So do we need normative concept? So when we want to represent normative directives, do we need to introduce concepts like obligations, duty, etc.? So if yes, which normative concepts do we need? And third, what do these concepts mean? So I'm like preparing that into presentation because one of the reviewer asked me to do that into my presentation. So I guess it's a good way also to start a discussion around that. So let's start from the first one. So do we need normative concept? Well, indeed, it is true that programs in themselves, they have a mandatory nature. What does it mean? So if I'm writing a is equal to true plus true, so that means that the system has to perform true plus true and put that into a register, which is associated to the variable a, etc. That's the same in Prolog or other forms of declarative programming. If I'm making a query, so that means that I'm asking the system to prove something. So that's a goal that I'm putting on the system, and the system has to do that. Similarly, if I have a rule, like if that's a dog, then it's an animal, then the system has to make the animal true if the dog is true. So that means that when we are programming this way, we are expecting performance, so that we are expecting that the system does what we tell it to do. But we can have another perspective towards computation, which is a perspective in which failure is expected. And there are at least two types of failures that I can pinpoint to. The first one is a violation, in the sense that certain components may not perform as required. And the second one, it's a conflict. So that means that there may be concurrent components in the system that may have incompatible requests. And then the problem is to understand how to solve that, perhaps giving priority to one of the components or the other. So already in the 80s, it was recognized that typically you need to introduce normative reasoning when you are into the second type of perspective. But the most important point is that the central problem is that who will declare that there was or there is indeed a failure? And if we think a little bit, this is actually the central problem, which is covered by legal systems all over the world. So let's assume that then we want to introduce normative concept. And so which kind of normative concept do we need? So again, looking at the computational literature, we can have control models, for instance, for access or usage control, in which we see that, for instance, we are denying connections from all type of websites, but we are allowing from example.org. So this is an example of Apache web server configuration. Or we could have languages or specification models that are based upon the ontic logics, that there is the logic of obligation, on prohibition, and permissions. Or like the most finer language is the one that are based upon Hohfeld's normative relationships, in which besides, so that first of all, they consider that there are two parties always involved. So if I have a duty, that means there will be always someone that has a claim towards my duty. And on the other hand, it introduces also a potestative dimension. So if there is a duty, someone created it at a certain point. So that means there was someone that had the power to construct this duty, and I was subjected to that power in order to have that duty created. So if I draw diagrams about this kind of perspective, then we see that the control models, they provide you permission and prohibition, and they are just about a party, and generally that's about actions. The ontic logics, they introduce also obligations, and they are typically concerns the content of this specification. It's about the situations. Hohfeld's framework, typically it introduces also the power, as I said before, the potestative categories, but that's about two parties always, at least it attempt to make explicit two parties, and that's about actions. So the third question was what this normative concept mean? Well, this is a long-standing debate. I mean, it starts from Greek philosophy, if not even before in other cultures. There is no shared agreement, and new semantics has continuously released. So I would say that the situation is rather terrifying in a sense. If I want to answer to this question, we need to represent how. By looking at these questions, well, I don't know even where to start because it's very dispersed. We have so many options, so many standpoints, several ways of looking at the problem. So I will take a kind of subtype of question, which is how to specify normative direction. So I'm not like trying to capture the full meaning. I'm just looking at how to specify them. So that changing questions, actually, we're entering into another arena. That's an arena of programmability, or readability, or cognitive accessibility, which was a little bit underlying also in the kind of questions and presentation that we had before. So I will take then a a recent one, that is the ODRL language, the Open Digital Rights Language. It has become like it's a WWW recommendation since 3 years. So this is a language that, if we look at the informational model, according to what I was saying before, it's about, it gives a primacy to the ontic categories because it's about permission, duties, every policy. It's about at least one of these three concepts associated to an asset and some party. But if we look at how it is written, then we see that essentially the most used way of writing ODRL policies is by utilizing JSON structure. And I do believe this is if you want, one of the assets that made this a success story within a certain type of technology. That's because essentially any IT practitioner is able to read through it. So for me, I had the impression by looking at these experiences that we are talking about lawyers, but generally the type of people that are going to write policies in technologies, they are kind of intermediate between legal people and, if you want, expert developers. They are rather in the middle. And that's in that middle that perhaps programming languages or specification languages for normative artifacts needs to play. So that's where we arrive on DPCL in a nutshell. So we start from a JSON-like syntax for the language, or for a specification language. We consider ontological intuitions that are foundational, that are expressed in other works, like in LKIF core, which is a legal ontology, and also cognitive linguistics, like the dichotomy between objects and events, and also in logic production systems, which is actually also behind the logical English, which is the distinction, for instance, between transformational rules and reactive rules. We introduce the final representational granularity given by Hohfeld's framework, and it is expressed in frames like iflint and iflint, with more frames and at the same time simpler type of frames. At the end, we are not going towards a full-fledged formal semantics. We are rather trying to identify a bottom line informational model. But still, I can show you that the semantics can be partially defined by means of rewriting rules, and we are also investigating using that as a way to investigate alternative standpoint to the usual type instance extensional semantics that's used in almost any type of formal languages. But we believe that this is more in line to how the qualification axe works in institutional systems. And we are also integrating by design a conditional preferential ordering to manage conflict. Because, as I said, this is a fundamental view over why we introduce normative reasoning. So I will make some examples. So this is about the entities. We have states that are written in this way, conditions, objects, and agent. And then we have transition events that are about change. So we have a syntactic difference, the dash symbol, to say this is a pre-event event. We can have production and removal event that are producing or removing objects, a little bit like assert or retract in Prolog. And then we have also qualification, disqualification events, like we can say that object is in group, is qualified as part of group, as member of group. So we can also utilize parameters to make some refinements. So in this case, I can write, I'm talking about a give action, but I'm refining who is the agent, who is the item, and the recipient. So in this case would be John is giving an apple to Paul, or Paul is eating an apple. Then I can then introduce the frames, as I was saying before, that are based upon Hohfeld's concept. So the first concept is the concept of power. So I can say that the priest has the power to marry John and Paul, and as a consequence, John and Paul are married. So notice that from the power in itself as a concept reifies an institutional causal mechanism, which is conditioned by the qualification of the agent, the priest, the procedure of action, and is affecting a limited domain of competence. So it actually represents a well-known view over power in law. Then we have the duty frame, like John has the duty to teach towards the university, has a duty to teach students, which is violated if John is not online. Imagine the situation of virtual teaching. So what I want to say here is that this duty like reifies an expectation for the counterparty. Generally, it's an expectation of good. So we expect that by teaching, the university will have something that needs that's needed for her. And I wanted to show here that I'm adding an explicit violation clause because sometimes violation may be defined independently of the content of the duty. I mean, we know that I cannot teach if I'm not online in a virtual setting, but this is cannot be seen explicitly from this frame. I can write it externally. So similarly, I can define some prohibition frames in which John is prohibited to go to swimming, and this prohibition is going to be terminated in the moment in which winter appears, is ending. So this is a negation. So this is an example of semantic neutrality, because in several languages, prohibition to do A is written as the obligation, so the duty of not doing A, while here I'm saying I'm neutral, I'm not taking a position over that. I know that there are logics that don't accept this view, so I'm just specifying it. Then there will be another moment in which I'm giving it the meaning to it. And also I wanted to show that, again, normative directives can have terminating conditions which are independent on performance, like time, for instance, time conditions. Finally, we have conditioning rules. We have conditioning rules in the language, so like transformational rules. So as long as it is raining, it is wet, or bike counts as vehicle. So as long as this object is a bike, that counts as a vehicle, or reactive rules. So in the moment in which it is raining, it becomes wet, or in the moment in which I raise my hand, then there is a bet. And typically contexts are generally involved in terms of transformational rules, like if in the context of auction, so as long as there is an auction, if I raise a hand, then there is a bet. I have an example. I guess I don't have a lot of time to go through it, but I will just go fast through it. So students can register as member of the library using their ID card. Is a power. So the student or the staff can register an action by means an instrument, which is the card, and the consequence is that they become members. But what does it mean to become member? Well, any member can borrow a book. So in this case, the power is to make borrowing. So I create this object, which is a compound object. I still don't know what does it mean. So I'm just saying I'm passing parameters to that. So the borrowing, there is a lender, a borrower, an item, and a timeout. And then I define somewhere else what borrowing means. So the borrower, for instance, by borrowing can be requested at any moment to return the item. So that means the lender has the power to request the return, and the consequence is to create a duty to the borrower to return the item. And there are also other components into this library regulation. So the borrower has the duty to return the item within the given date, and again, so there is a duty, the borrower towards the lender to return the item, and the violation is at the end of the timeout. And if the borrower doesn't return it, she may be fined. So this is an explicitly enforcement type of the directive, which is not necessary. I mean, normally in law we say that all duties should be regulated. There should be punishment somewhere, or some other form of enforcement. This is not automatic here, so there needs to be an explicit type of directive, like in this case. So that means if there is a violation of the duty, then the lender will have the power to fine the borrower, and the consequence will be the creation of a fine. So we are going towards the end a little bit to give more perspective on that. So the informational model of DPCL covers most common constructs and concepts that are observable in normative languages. and in principle, for that reason, can respecify directives that are written into other languages. But we can also utilize rewriting rules to re-encode certain constructs into others. This is just an example. So I can take all conditions, like preconditions in rules, violation, terminations, that implicitly refers to a power that may or should be assigned to someone, which is the case that happens during policy operationalization in an administrative setting. So let's imagine this case. So I have a prohibition to smoke. So that means that if this prohibition is holding, then if someone is smoking, then everybody will have the power to declare a violation with respect to that prohibition. And the consequence by declaring that will be that indeed we are stating that the P has been violated, the prohibition P has been violated. So this is actually very important because that's what we are doing when we are defining a social system, is to assign those powers. Who is going to declare that something has been violated? Or even another important point is that when things have been fulfilled. So in general, you could say that all deontic positions can always be associated to two powers. The powers to declare that these things has been fulfilled and that thing has been violated. And that will be a rewriting rule. So each time that I have a duty or a prohibition or a liberty, I do create two powers in which I could explicitly say who is going to have this power. So like in this case that I have a counterparty to the duty, I can say that the power of saying that it's upon the counterparty. It's a specific choice. It's a specific institutional choice. But with this language, I can make it explicit. And a final example, and then I will go into the conclusion. I take a very simple transformational rule. So this is objective. We don't have any normative concept in it. So like vehicle, if vehicle, then vehicle. So this will be like that in prologue. And we can read, indeed, the logic rules as goals. So the system has to make vehicle true if bike is true. There is a mandatory view over that. But we can transform then every transformational rule into two type of positions. A duty, so the mandatory duty. So anybody should construct the vehicle in the moment in which there is a bike becomes true, but also a power. So anybody will have the power to state that this is the case. So why I'm doing this passage is because in a social coordination setting, the mandatory view, it becomes less prominent. It becomes more important, the ability view. While here we are still assuming that the computer is going to follow what we want, while in an autonomous agent setting, this won't be the case. So I will leave this example to go into the perspective. So everybody here, I think, agrees that working on languages for computational regulatory function is a highly relevant and urgent topic. The literature is very dispersed, the opinion standpoints. There are new generation of research and practitioners that restarts from scratch things that were partially solved before. And I do believe, and that's for me an important message, that as a community, we should start by creating grounds and infrastructure to compare and organize all these experiences. And the practical standpoint of modeling practitioners that are not logicians, not expert programmers, are generally not taken into account by very few of those works. And besides, normative systems have certain characteristics that make them very different from standard computer engineering science practices. As I said before, for instance, the focus on failures and who is going to justify the failures. So DPCL started as an experiment just to design a programming language, starting for these alternative practical requirements. So it's more, if you want, a kind of creative settings. And we are very happy about that because so far actually it provided us a lot of new ideas. And we will have a first prototype of an interpreter in the coming months. So that remains to be seen where we are going to reach with that. And I've ended my presentation with that. Thank you very much.
Thank you so much, Giovanni. A reminder to everyone online to send in your questions through the Q&A. Do we have any questions locally in the room? All right, pulling up the Q&A online. Okay. First question, how does DPCL compare to other systems for annotating interpretations of legal rules like legal rule ML?
I guess we haven't taken the problem from the point of view of annotation. So obviously there are a lot of references to that, but the legal rule ML, it takes a specific choice of what are the underlying logical systems that are utilizing. So that's the feasible deontic logic by Guido Governatori. So there are a lot of choices that actually we don't want to commit with. And so the language should be sufficiently open to represent what is written into legal rule MLL, but also into other, if you want, normative directives that makes power explicit, for instance, which is not the case in the feasible deontic logic. So, and while the modeler should rather work in trying by means of rewriting rules to transform what you have as an input into what is your output of system that is going to reason with. So it's really a kind of lingua franca that we're thinking of. You could say that also those languages started from this perspective, because at the end, XML, it's a transportation layer. With some schema, you have some type of concept, but eventually, as an artifact, look to me that at the end, they took specific choices that are rather hard-coded into the standard.
Okay, thanks. And we have another question online. Do you have any plans for the formalization of the semantics of DPCL?
Yeah, no, so again, it's a question of, in principle, yes, I guess any type of actual application then will have a final semantic that will be there, but I would rather leave that open to the modeler to decide how to do that. So for instance, a couple of use cases that we are considering is that you could have DPCL that is describing general regulation, and at the end you may have part of that normative structure, which is translated into BCP policies, which are like routing policies for routers in data sharing infrastructure. So you see, you have a very technical artifacts with its own semantics at the end. So the bridges, I mean, if I'm taking a specific full-fledged semantics here, I don't know specifically how, I mean, I have less freedom to try to cut the part that are more needed for me for working the specific domain, application domain. In principle, I guess there will be some formalization, but it will be not in the normal sense that we are used when we are talking formalizing programming languages.
Okay, great. Thanks for a very insightful talk. Let's thank the speaker again.